quickly. So these are the problems one by one we'll see. First is just a warm-up problem. Let me explain the problem. We'll be having an array, and then we have to just increment all of the elements except one element, and then we have to finally get a state where all elements are equal. Now, how many minimum number of such operations you can do to get that uh, to get that equal number of elements in all array. So this is just a kind of, you can think solutions one by one, even programmatically how you'll do it, and even if you have other solutions, and yeah, you can quickly come up with some ideas. So someone can just say whatever he is thinking, so we can go in interview mode and others can also see.
I think one way to start will be to first of all uh, increase all elements except the maximum one,
Mm-hmm.
since we have to reach to that level.
Mm-hmm.
And like once other elements are also getting close to it, then we will increase this with all the other elements, something like that maybe.
Okay, let's go to whiteboard then. Let's see. We have 1, 2, 3 in the test case, let's say. Then what do you say? How do we go? First we increase 1 and 2
Yeah.
by 1. So it becomes 2, 3, 3. Now,
Now since like two values are equal, then we increase any of the like any of them.
no,
Maybe like
we have to increase all except 1. So you
yeah,
got
so
to
like 2 and 3.
2 and 3 you increase, then it becomes 3, 4, 3. And now you can
Yeah.
increase this 4, 4, 4.
So
So
maybe
you
like
get,
except for the maximum one, we increase the rest.
okay, you are saying always we for the maximum one except maximum, but in case there are multiple maximums like this case,
Mm-hmm.
you will increase all except the maximum. In this case it fits. Let's see some other case now. I'll show. So now what do? We take let's say 3, 7, and let's say 10. And how do we do here? So 3, 7, we increase, let's say 3 times to reach 10, 10. So 6, 10, 10. 3 operations. Okay, now you increase one of the two, 7, 11. Now you increase 10, 7, so 8, 11. Okay, I have some less space, just a second. Undo. Now what do you do? 8, 11, and then here 11.
Yeah.
Now from here 8 and 11 you will pick any one. So what will it be? 9, 12, and then 11.
Maybe
So
10 and 11, 9 and 11, but
yeah, so now 10 and 12 your logic.
yeah.
12. I guess this is taking how many steps? Let me check if it gives optimal. So according to the answer, okay, this
You have to go three more steps. Here.
3 more steps, yeah. So yeah, and 3. So how many steps is saying? 3, 4, 5, 6, 7, and then 3 more. Okay, let's see 3 more steps. 11, 13, 12. Now 12, 13,
Here we
13.
can't see where you are writing.
Yeah,
Okay.
yeah, this board is little bit difficult to handle. Okay, now 12, 13, 13. Now what do we do? Again 13, 14, 13. Now 14, 14, 14. Let's see how many steps did we incur here. So 3, then 4, 5, 6, 7, 8, 9, 10, 11. So yeah, the answer is 11. It's correct actually. Now how will you implement this programmatically? That's the question. So you'll keep incrementing except for maximum. And what's the time complexity? I also want to ask if someone can explain both. So programmatically it's clear. We except for all we keep incrementing. So what's the time complexity here?
We go n square.
Of
N
n
square.
square. So how do you explain that?
Like you take every one element and then you run a loop for all the other elements. So n into n
Right,
plus n minus 1. So for n large enough, we can ignore the minus 1. So n
right,
square.
right, right. So O of n square. Now can you come down a little bit? O of n, O of 1, anything is fine. So we have like 1 or 2 minutes more, you can think. There are two hats to wear always. One is mathematical, one is programmatic. Uh, we can go for sometimes mathematical hat, which is very useful. It boils down problem to nothing actually.
We should find out that how many, what will be the final array, and according to that we can just subtract it with the
How
lowest.
do you find what's the final array?
uh,
This is this is the final state. So how do you find from here to here?
uh, that we have to think.
Mhm. So let me give you a hint. Think the reverse way.
Can you show another test case, please? Like the other test case.
This one.
Yeah, sure. Is the answer 3 for that? Yeah.
Yeah. I
Okay,
guess
fine.
answer
Thanks.
is 3. Yeah, 3 steps are there. We reach 4. So now let me tell you the hint that you have to think reverse. Increasing all other elements means decreasing one of the elements, except for that indirectly. So
In that case, we can do it in big of in like arrays. The sum of all the elements of the array minus
exactly.
total number of elements into the minimum element.
Good. Yeah, that's the solution. So sum minus n times the minimum element, because we will be reaching by decreasing one every element to the minimum element. Good. So that's how we can boil this down to a very simple problem. So that's how sometimes mathematical art helps better than thinking always programmatically. Now here, let's come to this very interesting problem. So you can easily see by looking at the problem itself. I'll increase font more. So now it's visible, I guess. Is it?
Yes, we are.
So here we are just given an array, and now we have to find this if this triplet exists or not. If no such index exists, return false. So here we don't need to print any triplet. We just need to see if it's existing. So let's take the basic case. It's existing and it's not contiguous. It can be any ijk, but I less than j less than k, nums of I, nums of j, nums of k should form increasing. So how do you like this is false, these two. So let's go with basic approach first. What's the most basic approach here? I want to ask that.
It will be to run 3 for loops and like it will be big of n cube complexity.
Exactly. So let's go to whiteboard back. Let's remove some of the material here. Or So let me take a new section here. Increasing triplet subsequence, and this is not going. So what we have is here 3 for loops O of n cube solution, right? Now is there any other better solution we have to think? Can we do it in less time? O of n square, can we get down to O of n square?
Could you please explain the question again? I didn't get it properly.
Sure. So we have an array, let's say 1 2 3 4 5, simple array. Now from this we have to just see if there is any 3 indexes pair or 3 tuple that forms an increasing subsequence, 1 3 5 2 3 4, something like that. So now when we see, okay, let me take a new page here. It's becoming quick, so it will be easy to explain. So now what do you see? Sorry, you don't see anything. Let me draw first. 1 2 3 4 5. Okay, now yeah, you got the question. So we just have to return true or false if any 3 tuple exists ijk such that nums of I is less than, strictly less than, nums of j is strictly less than nums of k, right? Now maybe you can take 5 4 3 2 1. Here there is no such case, so return false. Very basic test cases. Now simple solution. Everyone got the question first. Let me if anyone hasn't got the question correctly.
Yes, I got it. Thank you.
Yep. So I hope everyone got it. So now accordingly we can just simple solution as said by one of you, 3 for loops. Just iterate over I, iterate over j, iterate over k, and find if there is existing. This takes O of n cube. And how much space? No space. O of 1 space. Auxiliary space. Okay. Handwriting is very bad. But yeah. N cube. Yeah. So now any solutions you can think, take your time, new solution.
Longest increasing subsequence. We find,
Longest increasing subsequence, right? But
yeah.
yeah, that will sure. So let us go in that direction also. Okay. Somehow my board is freezed. Yeah. Yeah. Now LIS. Does everyone know what is longest increasing subsequence, or shall I explain? Anyone if doesn't know, you can
Yeah,
tell, explain.
I think you can explain a little bit about it.
Yeah. So longest increasing subsequence is nothing but we find the in a given array, let's say a1 a2 a3 till an, we find the longest subsequence of ai aj ai plus 1, let's say, sorry, let's call it bi, b1 b2 b3. These are the indexes till bk. So these indexes we find in increasing order such that nums of bi, nums of b1, nums of b2 is also less than sorry, a of here, since the array is mentioned a, I will use a. I'll remove that nums. So now a of b of I, b of 1 is less than a of b2 is less than a b3. So you find such largest k. Basically, what's the largest k? Or shall I show a test case and then explain? This will be a little confusing. I'll show a test case and then explain. This notation can be confusing. So let's go here. Take a test case. So let's say 3 2 8 5 4 6 7 9. So here when we try to find the longest increasing subsequence, what's the longest increasing subsequence here? Can somebody volunteer? 3, 3, then 3 with 3 we can see 3, 8 also we can take. So sorry. So we can take 3 to 8, then 8 to 9. This is one of the subsequence which is increasing subsequence. So 3 of size 3. Now what do we do? We can have from starting from 2 here also. So 2 to 8, but 2 to 8 won't give us, again we have to go to 9. So let us take 2 to 5 here, then 5 to 6, 6 to 7, 7 to 9. This gives us 5. Yes, that's the highest one. So this is how we find the longest increasing subsequence. Now for now everyone can assume that there is a black box LIS which works in O of n square. So we have reached O of n square solution. There is DP solution. I won't go there because we have better solution here. Also with DP, but with understandable easy DP, so beginners can also understand. I'll explain that. Okay, does someone have any other solution from LIS, longest increasing subsequence? So how will we do? It gives us k longest. If it's greater than 3, we can always say greater than or equal to 3, we can say return true at the end, right, with this LIS algorithm. Now if someone has any new ideas, boiling down to O of n using some extra space, that's the hint. Use some extra space. Let's get back the test case here so everyone can see. 3 to 8, 5, 4, 6, 7, 9. Oops, I can erase this 9. Okay. Any ideas? Think how you can utilize some extra space. Can you store something?
I think like it will be a little bit like running LIS, the n log n approach, but we can optimize it because here we only need 3 elements, so uh, we can optimize that log n complexity thing.
Right. Can you explain a little bit more? Can you elaborate more how n log n can
So
we can?
we start from the beginning of the array.
Hmm.
So like if the array is empty, we take the first like 3 into the add 3 into the vector. Then we go to next element, that is 2. So since 2 is smaller than 3, we replace 3 with 2. So like the variant that we are maintaining is that our the array that we are making is always increasing.
So,
Okay.
yeah, I got it. Like you use the like you will be but that will again, I think we have to pop that. Okay, pop back will work in O of 1. So yeah,
Yeah.
so you use a vector extra space. So O of n log on n log n LIS, that is very rarely known algorithm. Now I recall. Yeah. So come down one more step to O of n now. This is how interview will work. This is how interview will be asking you anytime. You have to boil it down to lowest possible complexity. And if so there is competition in interview, whoever gets within time, you will have some 45 minutes. Now someone reached to of n log n solution, but someone reached to of n solution, then of course he will be the preferred one. So yeah, you have to think. Let me give you or if you can see time is there, but yeah, the next question is a little hard. So let me give you a hint. Can we store maximum and minimum in an array up to like a prefix of minimum, suffix of maximum? Everyone understands what prefix, what suffix? Prefix means from 0 to I, we store minimum for that ith element. Suffix means from n to some index I, we store maximum up to that. Now I think most of you have got the idea. What's the idea after storing? Can
Then we,
someone tell me the algorithm now?
yeah, like first we find the prefix minimum.
Yeah.
I think first year, second year should try.
Yeah. So if second year volunteers, it will be very good because you will be soon having. How many second years are there?
I
Let
think
us
all are,
count
most of them
some.
are second years only. Ishan, Pranav, Sachin, Sarthak.
Yeah, yeah. Please come forward. Other, you have to speak in interview. So feel free. Like you should get like a friendly, so friendly with this process that you feel interviewer is your friend at the end, and you try explaining solutions to him. So try. It's easy now. Now you have maximum, minimum of this, maximum of this. Now you are at this index. What else do you need? Exactly. So let's write it. Prefix of I is less than, let's say nums of I is less than suffix of I. So bear my handwriting here. So this will give us the solution in what time. Time complexity also you have to explain. What's the time complexity? To find prefix, what's the time complexity? Sorry? O of n. What's for the suffix? Symmetrically O of n. What's for this process? To go over all index? O of n. So what's the overall complexity? O of n. 3 times O of n, O of n. So this is very clear approach. Now it will be a challenging thing. Now this will bring out actual talent. This everyone is clear. If anyone has doubt, first ask this. This also dynamic programming approach. So now coming to the, does is everyone clear? Just say yes. Put somewhere yes or just say yes. So I'll go ahead. Next one is very interesting. In this only next one, come down to O of n, O of 1 space. How can you do that? You see, if you give this solution to interviewer O of n, O of 1, he'll be definitely happy. No chance he can reject you. So earlier we had space complexity of n. We want to use no space, just O of n approach. Third years I think can give a shot who do CP lot, and then yeah, their minds will be sharp at this. Okay, I hear a lot of silence. Am I audible or
Yeah,
any
yeah.
voice? Yeah.
Can we use some sort of a two-pointer approach, like one pointer in the beginning, one in the end, and uh, then like kind of a three-pointer only, but one in the beginning, one in the end. Then we go ahead and save a minimum value from the beginning.
Mhm.
So kind of like I'm trying, what I'm basically trying is to mimic this thing without extra space.
Right, right. You are close.
So we will start and we will have the minimum with us,
Mhm.
that we can save as we go ahead.
Mhm.
And with the second pointer, which is by in the end, we can like decrement it accordingly. Like if I am able to like come like say I just need an element which is greater than my current element.
So you mean whenever you have pointer 1 p1 p2 p3, so
Mhm.
now p1 is, let's say you have something at p1, so now what will you do with p2 and p3?
So like my P1 will have the minimum element index, then
Okay.
my P2 will be my current element, like the for which I'm iterating. So
Mm.
P1 will always be less than P2, like
Right.
elements, since P1 is the smallest,
Mhm.
and P2 will be greater. Now I just have to find an element which is greater than P2, like greater than the element at P2.
Then how will you do that?
Yeah, for that we have to think a little bit. Maybe
So what I'll do is, in the interest of time,
yeah.
uh, I'll code it just in front of ours. So let's see. It's very kind of not very intuitive, but yeah. So let's see. Here I'll do nothing. I'll just call this solve function. Let's say we have here for the time being. Let's take this. We don't need n here. We can just do any. Now what we do for int belongs to v, we, as pointed out rightly by you, we have something called small, and then we have something called bigger small. It is also small, but we I'll explain it how. But if somebody can explain when I write this algorithm, after that somebody can try to explain this. So s is I think I shouldn't put b here. Now if num is, I can make this boolean. So since we want to return uh, if num is less than or equals to s, then we have, sorry, s equals to num, else if num is less than or equals to b, we have b equals to num, else return true. Here we return false. Can someone explain this now? This is the solution. I think
Yeah,
Aditya, you told that solution, huh?
yeah. B will be somewhat like the second minimum element.
Yeah. B is the kind of, you said correctly, the pointer. We just need two pointers here,
Yeah.
P1 and P2. So whenever, but this is very counterintuitive. Whenever very minimum comes, we reside back to like completely. We don't assign it to the next big, or we don't check that. We just assign it to the smallest, well, direct minimum. Not the bigger minimum. We just assign it. This is like you need to it's very counterintuitive, but yeah, you can think how this works and you can figure out. But yeah, so it's as a homework. You can note it down and you can try to figure out uh, what's the thing, how it's working. You can print even array at every step, s and b at every step, and see. So that's how you will develop this computational thinking. When you do it on paper, you write down all s b variables at every loop, and then you can think why it's working. So okay, now coming to next problem, this will be very interesting. So this everyone does anyone have any doubts except for how this works that you have to figure out? Even I am very like I can only explain intuitively, but yeah, this is the thing. So any other doubts or any other solution like this mind blowing? Okay, so let's move on to next, shall we? Hello, any answer?
Yes, we are. We can move.
Yep. So we come to alien dictionary problem. Has anyone heard of this? This is actually very famous problem, by the way.
Yeah, heard of it.
Yeah. So those who have heard can enjoy the show. Others can interact. Now, alien dictionary. What is dictionary first? In the dictionary, what do we have? We have list of words arranged alphabetically. So in case of alien dictionary, it's the same. We are given some words arranged alphabetically. We have to figure out, but in this dictionary, the words, we have to figure out the order. What's the word? B can come before A can come after some Z, something like that. So from this given dictionary, we have to figure out what's the order of words. Now there can be multiple answers, because I'll explain how there can be multiple answers based on the given test case. So we have to figure out how to find out that order. This is very popular in interviews. So we'll begin with first. I guess there are a lot of second years here. So we'll begin with some standard things to be like a quick review. You can go back and delve into it deeply. I'll just go on a high level. So let's go on a high level. Let's go to whiteboard first. There are few things. Okay, if I go to that part, you will know the solution. First, let's think from top, like a naive solution, then go to that. Okay, then go to those things. So first, how you will do this? I'll ask someone. Someone has to volunteer here, and so everyone can learn to that process, question and answering. That's how interview will work. Let's go. Someone from second year, I only need. You learn a lot of concepts in this. Is very beautiful problem. It's very easy, right? Practical life scenario. Someone has to. I'll ask someone to volunteer from here. If not, who is there? Second years. So I see Sarthak. You there? Yeah. So just we'll play a question answer kind of thing. So you have to just think. So you know dictionary. In this dictionary, you can see BAA, ABCD, ABCA, CAB, CAD. So here, when I write this BAA and ABCD, so can you figure out which letter comes before which letter in this? In the dictionary, if exactly B would come before A. Apart from that, you don't know the rest of the order, because in dictionary you have some word. Let's say asterisk and one. So in this you can say A comes before B, but not about the rest of the order. S and A you can't compare. So right now, similarly ABCD and ABCA. What do you think here? What's the order? D is smaller than A, exactly. So okay. So now similarly, let's go for ABCA and CAB. Here A is C. So this kind of dependencies we can find, and last one is CAB and CAD. So here CAD. What's the order? B is less than. Now we have got this. So this is how we find orders of individual alphabets. But now we have to resolve this to find a universal order. This within this. So you have seen that it's kind of works like this. So some number AI is less than BI, and some BI is also CI is also less than BI. So we can't compare between AI and CI. They are both less. That's all we know. So we have to resolve this into a kind of a universal order, like some order. There can be multiple orders. So in that case, what I said right now here, if this is the case, you can give any order like AI, CI, and BI, or you can give AI, sorry, CI, AI, and BI. This can be the answer. These both are acceptable. So this is how we can get multiple answers. Okay. So now here we have to resolve all things. So you can't just go and write accordingly. Like multiple inequalities resolution is not like a programmable problem in a way. You can like not a like a programmable thing. You can just take this inequality and form order, but now this inequality comes and ruins that order. So you have to think a clear way. So someone has any thoughts on how to resolve these inequalities into an order? So finally we have to return this vector of resolved alphabets. Someone from third year can also attempt who has not solved this or seen this, because now third years will have idea more than second years here after this point. Anybody there can volunteer for me? Right. No, you make from D to A actually, because A will come afterwards. So we go from top to bottom. You can do reverse also, but then how you will do? You will get you can at the end sort reverse way. Yeah, that also works. But yeah, you are correct. The approach is that we form a graph. Who is this from second year, third year? Good. So you could at least visualize this as a graph problem. Now we have formulated this like what he's saying. I'll form in on whiteboard a graph from what we have seen. So what were the inequalities? First, let me write it down here. Uh, B is less than A. I'll draw here. B as a node. B is less than A, and D is less than A. So from D to A we have, and then A is less than C. A is less than C, and then B is less than D. B is less than D.
Excuse me, Via, are you like writing somewhere, drawing
Yeah,
somewhere?
yeah. Actually, I was.
Yeah, okay, now you can see it.
Yeah. So this is the graph we form as we spoke. Whichever is less, we make an edge from that to new one. So B is less than D, so B to D. B is less than A, B to A. A is less than C. Now it's a simple problem. Now on a given level, we have this level 1, we have this level 2, we have this level 3. In a given graph, we can always make it into a levels. So on a level 1, I will explain the concepts here now of the some of the concept of graph. Graph has a one concept called degree. So degree is nothing but there are two degrees actually, in degree and out degree. In degree means the number of edges incoming. So what I have drawn here is also wrong. This is not level 1. D comes at level 1, D comes at level 2, and A comes at level 3. D is below this edge we can always misinterpret. So let me explain this in degree concept and out degree concept. First let me correct this graph once again so I can explain it. How do I correct it? But okay, so uh, okay, I'll draw a new graph instead. This is very difficult to correct. So here we have B, we have D, we have D, then B and D to A both, D to A, B to A, and then A to C. Now in degree and out degree, what is in degree? Can anyone guess? It's easy. In degree is just the number of edges coming onto that node. For every node, we define in degree as number of edges coming into that node. So this is coming into D. So in degree of D is 1. So on B, what is the in degree of B? Can anyone quickly tell?
0.
0. In degree of B, D is 1. In degree of A, in degree of C, 1. Now what we do is, based on this in degree, what we can and the levels, based on the in degree and levels, what we can do is form an order. So on the level 1 this is B, on the level 2 this is D, on the level 3 this is A, on the level 4 this is C. So we resolve this into a kind of order. So here in this case, at every level there is one node. There can be multiple nodes with in degree 0. So there can be here X, let's say. So we'll have an order in which B can come before X or X can come before B, as seen. Or on a same level we can give any order. But below, as we come down, we have to maintain that order just in the hierarchy. So this is how we get the order resolution. So this problem you will see is known as topological sorting after you form this graph. So here what you do in topological sorting is, parent always comes before, let me I'll explain this topological sorting. Topological sort. So in this we form an array of let's say nodes in which parent always comes before child. So this is the array. So there can be multiple orders. So parent coming before child, as we discussed. This can be parent of D, so B can come before X, but child is always in the. So that's why there are multiple orders for topological sort. In this also similarly we can have any order. So how do we solve this as a topological sort? Now this problem boils down to topological sort. So what's the how has anyone solved this topological sort problem? How to do a topological sort on graph? Given such a graph, how will you do a topological sort? Okay, let me explain this. There is concept called level order traversal in a graph. As we discussed, this level 1, level 2, level 3. We go level by level and put the nodes in a queue, and then we whenever it's popped, we push its children to the queue. So this is called breadth first search. So we say we are searching the breadth. There are two actually main algorithms I recommend everyone to look if they are not seen in graph. There is depth first search and there is breadth first search. These are very basic algorithm. Any graph problem boils down to this at the end, DFS and BFS. So this problem is solved by breadth first search, and we can do a just a level order traversal one by one and put that. And but we have to keep in a case of topological sort, we have to keep this in degree also in mind. So accordingly we do a depth first. So is the solution clear? How do we resolve this? Does anyone have doubt? We'll move to code. We'll quickly code it, like within 10 minutes. I'll take 10 minutes to code this, so you'll have an idea of how breadth first search went. So what did we learn in this? There are a lot of things. What okay, so I'll write it down here. One is BFS, topo sort, graph, formulating a graph problem from given. So like that. So these are the various concepts involved here. And now let's move on to, if anyone has any doubts, in fact this dependencies problem, resolution problem, you'll see everywhere. So basically we call this as a dependency. So D depends on B, A depends on B. So in operating system you will see there are task scheduling. So there is some dependency that this task can only be done when this is completed. So let's say this is the task, this task can be only done when, so we formulate it as a graph problem and then resolve, we formulate to schedule this task, we do a topological sort. then it's scheduled according. You will see a course scheduling problem in this. So for taking a particular course, one student has to take another course. So again, this problem is can be solved by topological sort. Form a graph of course one from edges, whichever is the dependency. They will give dependency in terms of pairs, like this course is dependent on this course, this one. You will have a pairs, vector of pairs, and then you form this graph, and then again just do a topological sort. You have the order in which to take the courses. So this is the universal problem at the end, topological sort. So that's why we come to code and we see how to do that. Okay. Is it fine if anyone has any questions? This will be a little challenging. I haven't touched to code a long time. So okay, let's start. We can have a vector of string. Let's say dict equals to. Let's copy this. Dict equals to this. Okay. Now what? N and k we have, which we can figure out through this. What's the k? Okay, k are the number of alphabets. Now I haven't discussed about one thing, which is the h case in this, but that won't occur. For now, for simplicity, you always assume that there is existing order. There can be case that there is cycle in this graph. So then we can't resolve it. In operating system, that is called deadlock problem. We can the task get into cycle, so that can't be resolved. So we have to remove either of the thing. But yeah, I won't go there. We can, for now we can assume that this can be resolved into some alphabetical order. Let's go and see how do we do this now. Now we have vector dict and then n. And now what do? We need to form a graph. So map of char comma vector of char. Let's have a map, hash map, which stores that who are the children of this stores the children to a particular character. Since in this graph we can see one can have multiple children. B can have D. B has D as the children. B has A as the children. Let's go there again. Quickly code it, and then we have to store in degrees for every node. So in degree of, okay, we need k here, of course. That's why, because we need to specify in k. Let's in k is equals to, in this case it's, what's the k here? 4. In degree of k, and it's initialized to 0. Now what we do? So do we do it for comparison for this string with every other string, or do we just do with adjacent one? I guess we can do it with all to find out all. Yeah, but basically that would be covered in that case only. That's what I'm thinking, to optimize it or not. Okay, yeah, let's go with all. Now what do? We have string s1 equals to dictionary of I. String s2 equals to dictionary of j. Now we can have k equals to 0 while k less than minimum of length s1 dot length 2. This is for that thing that we need to find the first mismatch and then record that record that dependency into graph. So and s1 of k is equals to s2 of k. So we do k plus plus. So right, and now if there is no we see, and there can be a no mismatch case as well, so that we have to edge case check. But here let's go for the thing that we just put mp of char is s1 of k. So s1 comes before s2, right? Yeah, so s1 of k dot push back s2 of k. That's how we get the graph. Now here we just have to check if s1 of k is, if k uh, is basically less than s minimum of s1 dot length and s2 dot length. Okay, this is just a edge case check. If it's overflown here, then we don't need to do this, we can't do this. So now we have the graph. Now just what remains is just the topological sort. So we have q of character q. Also we need to store the in degrees first. For uh, here we can just do, whenever we push back here itself, we can do in degree plus plus whenever we push. Sorry. So here what do? We do in degree of s1 of s1 is it s2, is it is s2 of I minus 0. So since we have in degree with indexed with integers, vector of int, so that's why minus this 0. So in degree plus plus. Now we just have simple q of character, q of character q, and then we just iterate over these characters.
Yeah, in line numbers 18, are we writing S2 of I or shouldn't it be S2 of K?
Yes, sorry, s2 of k. Thanks for correcting that. Now we go here and over what do we iterate over all the characters that we found in this. Basically we can just go over assuming this problem has only uh, assuming that this problem has only small character cases. For now we can anyway create this vector of here we can create all 26. So what happens is, assuming that you have a to z all only lowercase characters in this dictionary, and whatever doesn't come in this, you can always give them before this. Let's say z is not coming here in this any of the alphabet, so you can always keep it anywhere whoever doesn't come. So you will see that submission has passes that. So here if otherwise we can create a map initially. Here what I'm assuming that we have to give order of every 26 alphabets, and putting whichever doesn't comes whatever alphabet doesn't comes, we'll put it in any order. So if not, we have to create a map again of characters which are available, and then create this in degree, and then just give the order within that. Otherwise we can follow this: I is equals to 0, I less than 26, I plus plus. If in degree of I is equals to 0, then q dot push. Here we have to push I plus a. Here I have to not 0 a, I plus a, and now we go for topological sort. So q is not empty. So char ch equals to q dot front and q dot pop. Now for auto or yeah, x belongs to MP, we can do. So we MP of, or what we can do is for char ch belonging to MP of char ch is already taken. Char c belongs to MP of ch. Now what we do is in degree of. So this is topological sort algorithm. Whenever we visit a node here, I'll explain on this on board. Whenever we visit any node here in the BFS, we remove this node. So its in degree is also reduced. Since this parent is gone, now its in degree is reduced. This edge will be removed. And then we resolve only this remaining. So that's why we are removing the level 1. Then we remove these all edges, and this level in degree all reduces by 1. I guess that's easy to understand. Moving ahead to code. So in degree of C, in degree of C minus A minus. Now if in degree of that becomes 0, then we again push it to Q. In degree of C minus A is equals to 0, then Q dot push. And here also we have to store, of course, the result vector of char result. Our result is there. So here we just push result dot push back character ch, and here we just push again this character c. That's all, I guess. This is like a pseudo code. This is not correct, but I mean this might have some debugging problems, but yeah, on a high level this is the case. If somebody knows, can correct me anywhere I'm going wrong in BFS or anything. This is fine. Do I have the code? Yeah. Now let's guess. It's 12, so it's time to end this session. So I'll say, to practice this problem, whatever we have discussed, just search these names. I'll put this in chat at the end, in the Discord at the end. So alien dictionary is very famous problem, by the way. I have solved this at coding ninjas, I guess. So here you will see my solution, but yeah, this is the thing. Yeah, that's correct, I guess. That's all we have to do here. BFS. And how simple is it? Now it feels it's actually categorized hard problem, but once we boil it down to simpler and simpler problem, it becomes easy. It's just topological sort at the end. So Aditya, do we wrap up
We can
here?
wrap up.
Yeah.
Yeah.
So I have few things to tell here. Practicing for interviews. One thing is, while you practice any hard question, take at least solve one hard question, I'll say, in one day, and try to explain at the end you to yourself how you'll explain to interviewer. To medium questions you can easily explain, that's not a problem. To hard questions you should try to explain it to yourself, and then see where you are going wrong and all, and you try to code it by speaking out loud and all. Also, due to this pandemic, actually interviews are happening online, but when you will go offline, most probably you will face that board interviews. So I have heard that they take these interviews on board, and you have to write this code on board with pen, and there will be one interviewer panelist who will code it in whatever you write on board. He will code it and check if it's valid. Yeah, so you have to cover that. So yeah, that's all from my side. Hope you enjoyed this session. Thank you
Yeah,
for
thank you.
coming.
Questions were really great. I think all the three, because like usually when we see topological sort problem, those are very basic problems only.
Yeah,
But this
right.
is the only topological sort problem which you will feel that okay, it's not that intuitive directly.
Yeah, yeah. But
So
once we boil it down, it becomes like a simple problem again. So
yeah,
it's basically breaking down again in interviews also. So yeah, same thing. Thanks all. I'll stop this sharing my screen. Any doubts you guys have, you can ask.
I will also say that like you should practice these problems at least once, see that how they are done. So then you will get to know that okay, this is the thing, because I think, I'm assuming that most of you don't know about graphs and dynamic programming, but once you start it, then you will get it slowly and slowly. Don't think that once a course come, then I will start studying dynamic programming and graph. I mean, it's a very big mistake. Many of us did it, but you don't do it.
Yeah.
Start now only.
Yeah, I guess these second years are still participation is less. I guess yeah, I'll talk to you offline. So
Yeah, I mean, we will be coming so.
mm. No, I mean offline. I'll talk on phone somewhere. So
Okay, okay,
yeah,
sure.
yeah, yeah.